Welcome back to All This Math. This is Professor Parker, and make sure you are subscribed to the All This Math YouTube channel, and also like the video, share the video, tell people what we're doing at All This Math. All right. I do want to give a shout out to Prairie View A&M University down in Houston, Texas. Um, the late Jacob Carruthers taught there at one point. Also, a very important brother, Sundiata Kohli, also attended there and majored in mathematics. He actually was very close to this woman up here, Asada Shakur, right? Um, yeah, definitely want to shout them two out. Definitely. And if you're unfamiliar with those two people, Sundiata Kohli and Jacob Carruthers, please do your research on them. All right. Now, you see written on the board Facebook math. I'm calling this Facebook math because this is a problem, an example problem written like this that I saw on Facebook and I shared it with some people. And there still seems to be some confusion about how to approach problems like this. All right. Now, we're using the order of operations. All right. The order of operations is what it is, right? The order of operations actually removes ambiguity in terms of problem solving when you're given an expression. Now, you might notice that there seems to be three iterations of this problem written on the board, right? This looks similar, but this is not the same thing as this. Let's be clear. This is not the same thing as this. This is not the same thing as this, right? This is actually equivalent to this. These expressions are equivalent, even though they are written differently. This is written in fractional form. This is written horizontally. These are equivalent to each other. This is not equivalent to this. This is not equivalent to this. All right. So that's why we should get two different answers when we simplify these expressions. These are going to get this. These are going to result in the same answer, and I'll show you that. But there will be a different answer for this because we're going to follow the order of operations. The order of operations. All right. Some people call it PEMDAS. PEMDAS oftentimes confuses people because in PEMDAS, the M is before the D. Multiplication comes before division, which confuses people and has them thinking that you should always multiply before you divide. That's untrue. You multiply or you divide depending upon what you see first as you read from left to right. That is the rule. That has always been the rule. Math did not change. The order of operations did not change. It has not changed. No one can show me documented anywhere in any textbook anywhere where there was always multiplication before division, regardless of whether which came first going left to right, and documented in any textbook. And I've asked many people, right? I've even done some of my own research to look for this, to no avail. So now let's work this out. Now the order of operations says that, where's my marker at? Oh, here you go. We work on everything inside the grouping symbols first, right? The grouping symbol. So these parentheses are a grouping symbol in this context. So we got 7 minus 3. All right, so we're going to do that first. We're not going to multiply first. We're not going to divide. Now, this is what a lot of people think they should do. They think they should distribute the 5 to everything inside, but you can't do that because that disrespects the order of operations. Because if you do that, you're putting this multiplication before this division. And the order of operations states, regardless of whether you want to believe it or not, you can't argue with it. It is what it is. It is what it is. And I said that on another order of operations video that I did because I can't think of any better way to describe it. You multiply or divide according to what you see first as you read the problem from left to right. As we read this problem from left to right, we see 60 divided by 5 times the quantity of 7 minus 3, or 5 times the difference between 7 and 3. Division comes first. So therefore, if you have to decide between doing division and multiplication first, you would divide first because the division comes first. That's just what it is, right? I don't know any other way to say it. That's just what it is. So by doing distributive property, what you would be doing is, again, disrespecting the order of operations because then you're doing multiplication before you're doing the division, which comes first, which in fact does come first because you see the division sign right there. That's to the left of this juxtaposition, which represents multiplication. All right, so let's look at this. So this becomes 4. This is still a 5. This is still a division sign. This is still a 60. Now, another part of confusion, source of confusion is this. These parentheses, they're no longer a grouping symbol. There's no group. There's nothing to group. It's just a 4. So these parentheses only represent multiplication. We could switch this out and rewrite it like this. We could say 60 divided by 5 times 4. That would be equivalent to this. This would be equivalent to this. Now, some people make the argument that this is ambiguous and this is not good math if it's written ambiguously. I would say that I understand their point of view, understand their position, that there are ways to write this which would make it more clear, right? For example, the person that originally wrote this problem, they could have wrote parentheses around the 60 divided by 5. They could have did that. But we don't need to do that. If we know the order of operations and we follow the rules of order of operations, we don't need to write an extra set of parentheses. That's superfluous. We don't need that. As long as we know the order of operations. Right? So this is 60 divided by 5 times 4. So again, we divide first. Why do we divide first? Because the division comes first as we read the problem from left to right. 60 divided by 5 is 12. And then 12 times 4 is 48. So the final answer to this problem is 48. Now, like I told you, this is not equivalent to this. Even though a lot of people, when they see this problem, they automatically think this. They interpret this problem as this. They should not be doing that, though, because this problem is not this. This ain't that, and that ain't this. This ain't that, and that ain't this. All right? Now, when we say fraction, with a fraction, the numerator or the denominator has what we consider a grouping symbol, even if it's unwritten, an unwritten grouping symbol around it. So we would simplify everything in the numerator first, and there's nothing to simplify because there's only a single number of 60. In the denominator, we have 5 times the quantity 7 minus 3. So we would simplify all of that entire denominator, right? Because when we deal with numerators and denominators, the denominator has an unwritten grouping symbol around it. The numerator has an unwritten grouping symbol around it. So that means you do everything inside that grouping symbol. So we simplify the whole numerator and we simplify the entire denominator. In this case, the numerator is already simplified. It's just 60. The denominator can be simplified though. So now we're going to have 60 and then 7 minus 3 is 4. We know to work out what's in the written parentheses first, which is 4. And actually, we could use distributive property here because there's nothing preceding this 5. So either way, you're going to get 20. Whether you do 7 minus 3 and get 4 and then do 5 times 4 to get 20, right? Or you distribute the 5, you get 35 minus 15, you still get 20. Either way, you're going to get 20. But doing that is cool now because it's not like up here. This division sign precedes the 5, which means you can't just go ahead and multiply just because you feel like it before you deal with the division sign. We can't do that. That's bad math. So we got 5 times 4, which is 20. And then we got one operation left, which is 60 divided by 20, which is 3. So like I told you, this ain't that, that ain't this. That's why the answer to this is 48. The answer to this is 3. They're two different problems. They appear to be written, they appear to be equivalent, but they're not. They're not the same thing. They're not. Now let's go down here. 60 divided by the quantity of 5 times the quantity of 7 minus 3. Like I told you, this is equivalent to this because we would simplify everything inside the brackets first, and then we would take 60, which would be our dividend or our numerator, and divide it by whatever product we got inside of these brackets. So inside of these parentheses, we got a 4, and then the 5 times 4 gives me 20. So I got 60 divided by 20. And what's 60 divided by 20? Or think about the concept of division. How many 20s can fit into 60? How many 20s can fit into 60? How many groups of 20 can fit into 60? 3 groups. 60 divided by 20 is 3. Just like 6 divided by 2 is 3. Because you know 2 times 3 is 6. And you should memorize your multiplication facts, despite what a lot of people on the internet think. Don't listen to them folks. They're setting you up for failure. Memorize your multiplication facts. I stand on that. Memorize your multiplication facts. So because 6 divided by 2 is 3, 60 divided by 20 is 3. So like I told you, I ain't lied to you. See? Same thing. Because this is the same as this. This is the same as this. They the same thing. That's why we get the same results. But this is not the same as this, and this is not the same as that. That's why we get a different answer. Because we approach it differently. We approach it differently. And we follow the order of operations. So that's just something I just wanted to point out to you. Because a lot of times, like on Facebook or on Instagram or on the internet or in a classroom somewhere, when people get these problems wrong, they get them wrong because they're misinterpreting the expression. They're misinterpreting the expression. Just like when somebody's reading a book, it's possible to misread a book, to misread a paragraph, to misread a sentence, to misinterpret a sentence, to misinterpret a phrase. That's very possible. People do this in mathematics. A lot of people read this and they assume that there are a grouping symbol around the 5 times quantity 7 minus 3. It is not. It is not. If it was meant to be one, it would be there. But if it's not written, then it's not there. So we shouldn't act like it's there. Right? Now, with a fraction, we can act like it's there because that's part of the rules. It's part of the rules of the game. In a fraction, the numerator has an unwritten grouping symbol around it. The denominator has an unwritten grouping symbol around it. That's part of the rules. That's part of the language, part of the rules of the language of mathematics. Here, the grouping symbol is actually written. See, up here it's not. Down here it is. Because it's written down here, we act like it's there because it's actually there. We cannot just assume that it's there. In the absence of that, we follow the order of operations, which says that after we deal with the grouping symbols that are written, right, or understood to be there, right, based upon rules, we multiply or divide from left to right. I mean, there aren't any exponents in this problem, so we ain't worried about exponents because there aren't any exponents in this problem. Well, technically, there are exponents. Every term or number has an exponent, but if no exponent is written, that means the exponent is a 1. And if your exponent is a 1, that doesn't affect anything. This is really 60. We could say that this is 60 to the first power. We could say this is 5 to the first power, 7 to the first power, 3 to the first power, or 3 to the first power, because it's minus, not really a negative 3, minus 3 to the first power. That doesn't affect anything though, right? But we divide first because we do division first, then we multiply because we read from left to right. That is a seemingly minute detail, but it's a very important detail that a lot of people leave out when they are attempting to simplify mathematical expressions using the order of operations because they're too overly reliant on PEMDAS and these mnemonic devices that get people tripped up all the time, right? It could be PEDMAS. It could be GEMS. It could be JEDMAS, right? G standing for grouping symbol instead of parentheses because you might have brackets. Because if you're a person that's caught up in PEMDAS and then somebody give you a problem with a bracket, you're going to be sitting there thinking like, what am I supposed to do with that? What's that? I know PEMDAS, the P stands for parentheses. What am I supposed to do with brackets? Well, PEMDAS, the P in PEMDAS or parentheses is an example of a grouping symbol. So really what we're talking about is a grouping symbol. That's what we're talking about. We're talking about grouping symbols, right? We're not talking about nothing else. We're talking about grouping symbols. All right, so we just got to know the rules and just accept the rules. Some people know the rules but don't want to accept them. So they prefer to like do a problem like this and get 3 because they don't want to follow the order of operations. They don't want to follow it. And that's fine. But, just say what it is. You don't want to follow the order of operations if you get this answer and you actually know the order of operations. You divide or multiply as you read from left to right. There is no bracket around this. There's a bracket around that down here. There's none up here. Down here, not up here. Down here, yes. Up here, no. Down here, brackets. Up here, no brackets. This is why we get different answers. All right? Support your HBCUs. Do your research on Prairie View A&M University down in Houston, Texas. Research Sundiata Kohli. Research the late Dr. Jacob Carruthers. And I'll see y'all in the next video.